Let us solve question 2. So A part, evaluate limit x tends to 0, x square plus 2 cosine x minus 2 divided by x sin x, and it carries 2 marks. So here limit x tends to 0, x square plus 2 cosine x minus 2 divided by x sin x. So whenever there is x tends to 0 and sin x or tan x, we should do like this. We should use the result limit x tends to 0, sin x by x is equal to 1. So if we use this result, it will become limit x tends to 0, x square plus 2 cosine x minus 2 divided by x. Now we divide by x and multiply with x. So that will be x square sin x by x, and when we take limit x tends to 0, sin x by x, this will become 1, and so we have limit x tends to 0, x square plus 2 cosine x minus 2 divided by x square. And if we take limit x tends to 0, then cosine 0 is 1, x tends to 0, so this is 2 minus 2, so that is 0, and divided by x square, so this is 0 by 0 form, and we apply the L'Hopital rule. So taking derivative separately, numerator and denominator, derivative of x square is 2x, derivative of cosine x is minus sin x, so this is minus 2 sin x, derivative of 2 is 0, and derivative of x square is 2x. So we can say that limit 2 can be taken outside. So this is x minus sin x divided by x. And if we take x tends to 0, sin 0 is 0. So again this is 0 by 0 form. So again we can apply the L'Hopital rule. So limit x tends to 0, derivative of x is 1, derivative of sin x is cosine x, and derivative of x is 1. And now we can see that when we take x tends to 0, cosine 0 is 1. So this is 1 minus 1. So this is 0 by 1, and 0 by 1 is nothing but 0. So that is the answer. Next, B. Find nth derivative of y equal to 1 over x minus 1 x minus 2. So that also carries 2 marks. So we need to find the nth derivative of 1 over x minus 1 x minus 2. So now, so we can have like this, y equal to 1 over x minus 1 x minus 2. Let us have the partial fraction. So we can write a over x minus 1 plus b over x minus 2, and therefore we have like this, y equal to a into x minus 2 plus b x minus 1 over x minus 1 x minus 2. And so we have, now y is nothing but 1 upon x minus 1 x minus 2. This is 1 upon x minus 1 into x minus 2. So these two will be getting cancelled, these two. And so we have 1 equal to a into x minus 2 plus b into x minus 1. And now we find the value of a and b. So let x is equal to say 1. Then left side is 1. A into 1 minus 2, and therefore a equal to minus 1. We take x is equal to 2. Then we have a 1 equal to, this is 0, and this is a b 2 minus 1. So b equal to 1. And so we have y equal to a upon x minus 1. So minus 1 upon x minus 1 plus b upon x minus 2. So plus 1 over x minus 2. And so now this is standard formula yn. So this is minus 1. It is 1 upon ax plus b formula. So that is minus 1 power n factorial over x minus 1 power n plus 1 plus minus 1 power n factorial over x minus 2 power n plus 1. So we can write like this: minus 1 power n factorial 1 over x minus 2 power n plus 1 minus 1 over x minus 1 power n plus 1. Next, see. So it says like this: if y equal to sine inverse x, prove that 1 minus x square y2 second derivative minus x y1 equal to 0. Second, 1 minus x square y n plus 2 minus 2n plus 1 into x yn plus 1 minus n square yn equal to 0. That is of 3 marks. So let us solve this example. Y equal to sine inverse x. So let us differentiate with respect to x. So then y1 equal to derivative of sine inverse x is 1 over root 1 minus x square. And so we can write root 1 minus x square y1 equal to 1. Let us take square. So squaring on both sides. So if we make the square, this is 1 minus x square y1 square and is equal to 1. Now let us again differentiate with respect to x. So then 1 minus x square says it is derivative of y1 square. So that is 2y1. And again we use the chain rule. So derivative of y1 is y2 plus y1 square as it is. Derivative of 1 minus x square is minus 2x, and derivative of 1 is 0. So 2 and y1 is there. So we can take like this 1 minus x square y2 minus x y1 equal to 0. So that is the proof of the first. So 1 is proved. Now we would like to prove the second. So nth derivative. So now there is a Leibniz rule. So we apply the Leibniz rule. So differentiate n times. Okay, differentiate this one n times by using Leibniz rule. So what is that rule? So let us take derivative n times. So first let us take up this term. So it is 1 minus x square yn plus 2. y2 is there and again n time derivative. So yn plus 2. Then plus n, that is nc1. Okay, nc1, that is n. Then take the derivative of this and reduce the derivative of this yn plus 2 by 1. So that is minus 2x, and derivative of yn plus 2 let us reduce by 1. So that is yn plus 1. Okay. Then plus nc2. So nc2 is n minus 1 by 2. So n minus 1 by 2. Then this derivative is minus 2, and reduce the derivative of yn plus 1, and that is nothing but yn. So that is the nth derivative of 1 minus x square into y2. Then minus. Let us take the nth derivative of this. So x, nth derivative of y1 is yn plus 1. Then plus n c1, that is n, derivative of x is 1. Reduce the derivative of yn plus 1, that is yn, and equal to 0. So now simplify. So therefore this is a 1 minus x square yn plus 2. Now where are yn plus 1 terms? So here yn plus 1, here also yn plus 1. So let us take these two terms. That is, let us take minus outside. So this is minus sign, then 2n here, then here it is plus 1, and x times yn plus 1. Now here 2 and 2 will be getting cancelled, minus sign is there. So let us take yn. So plus, so this 2 to cancel, n and yn. So n and yn is there. So let us write, and the minus sign is there here as well as here also. So let us keep minus. Okay, so minus, then n yn. Okay, so here it is n minus 1, and here it is plus 1. Okay, so we have this 1 cancel, n into n, n. So we have 1 minus x square yn plus 2, then minus 2n plus 1 x yn plus 1 minus n square yn equal to 0. So that proves 2 also. Okay. Now here we have one more question in OR, and it is like this. Says find Taylor series of 10x in powers of x minus pi by 4. Hence, find approximate value of 10, 50 degrees. Okay, so let us solve. So Taylor series of 10x in powers of x minus pi by 4. So here we know the Taylor series of fx in powers of x minus a. Okay, so that formula we have to apply. So let us take y equal to fx is equal to 10x, and here a equal to pi by 4. So f of pi by 4, or you can say y at pi by 4 equal to 10 pi by 4 and is equal to 1. Let us take the derivative. So derivative of 10x is sec square x. So y1 at pi by 4, or you can say f dash pi by 4, and that is sec square pi by 4. Now you know sec pi by 4 is 1 upon cos pi by 4. Cos pi by 4 is 1 by root 2. So 1 over cos pi by 4 is root 2, and sec square. So root 2 square, and so that is nothing but 2. Then second derivative y2. So derivative of sec square x. So derivative of sec square. So it is 2 sec x, and use the chain rule. The derivative of sec x is sec x into 10x. So that is nothing but 2 sec square x into 10x. Can I write like this? This is 2 sec square x is y1 and 10x is y. Okay, and now the value at pi by 4 is 2 y1 at pi by 4, y at pi by 4, and so this is equal to 2. What is y1 pi by 4? y1 pi by 4 is 2. Okay, and y at pi by 4 is 1, and so that is nothing but 4. This will help in more number of times derivative. So suppose I want y3 third derivative, then 2 derivative of y1 is y2, and keep y as it is, plus 2 keep y1 as it is, and derivative of y is again y1. So this is 2 y1 square. So now y3 at pi by 4 is equal to 2 y2 at pi by 4, y at pi by 4, plus 2 y1 at pi by 4 and its square. So y2 at pi by 4 is 4, y at pi by 4 is 1, then 2 y1 at pi by 4 is 2. So this is 2 square. So this is 4 2 8, 8. So that is nothing but 16, and so on. So now by Taylor series, um, fx, that means 10x, in terms of in power of x minus pi by 4. So what is that formula? F of x is f of a. So f of a plus x minus a into f dash a, that means f dash pi by 4, plus x minus a square pi by 4 square by factorial 2 f second derivative at pi by 4, and so on. Say x minus pi by 4 cube by 3 factorial f third derivative pi by 4, and so on. This is y at pi by 4, this is y1 at pi by 4, this is y2 at pi by 4, this is y3 at pi by 4. So 10x is equal to f of pi by 4 is 1. So this is 1 plus f dash pi by 4, that is f dash pi by 4 is 2. So this is 2 into x minus pi by 4 plus 1 by 2 f double dash f second derivative pi by 4, that is 4. So this is into 4 x minus pi by 4 square, plus this is 3 factorial, so that is 6 f third derivative pi by 4. So f third derivative is pi by 4, that is 16. So 16 x minus pi by 4 power 3, and so on. So this is select 2, 3, and 8. So this is the 10x in powers of x minus pi by 4. Okay, like 10x is equal to 1 plus 2 into x minus pi by 4 plus 2 into x minus pi by 4 square plus 8 by 3 x minus pi by 4 cube, and so on. Now we would like to find out the value of approximate value of tan 50 degrees. So now this is radian pi by 4 and so on. So we need to convert into radian. Okay. So this 50 degree is nothing but 50 pi by 180. This is radian. Okay. And now 50 x minus pi by 4, you can see that the terms x minus pi by 4, x minus pi by 4 square, x minus pi by 4 cube. So x minus pi by 4 is 50 pi by 180 minus pi by 4. Now you use the calculator. If you use the calculator, you will find this value as 0.082726 something. So if you make it round up, it will be 7. So 0.08727. So now from here, tan 50 degree, and that is approximate value, is 1 plus 2 into x minus pi by 4, that is 0.08727 plus 2 into 0.08727 0.08727 square plus 8 by 3 into 0.08727 cube and so on. And now you simplify, use the calculator, and you will get this as approximately 1.19175. So this is your answer. Thank you.